Hi, kiddos. So today we are going to be working on patterns. Now, patterns is something that you have been doing for quite a while now. You've been exploring patterns since probably actually even pre-K, kindergarten. So we're really just going to kind of build on that a little bit. Where this whole unit is really focused on the coordinate plane and graphing points and graphing patterns. So we have to make sure that we understand patterns, that we understand determining a rule, that we understand figuring out what's happening in a pattern before we can start graphing them. Okay. So we actually have two lessons today. We're doing two because this first one, well, really, actually, both of them are pretty easy cheesy. So let's go ahead and get started. I need you to get to page 507 with me. And we're talking about first building patterns or kind of looking at pictures, generating them. Okay. So this first pattern is made from toothpicks. If you want to go ahead, if you have toothpicks at home and you want to go ahead and get those out, feel free to. If not, then you can just rely on drawing them. Okay. So the first figure has 4 toothpicks. So in figure 1, there's 4. The second figure uses 7 toothpicks, and the third figure uses 10. Okay, let's assume the pattern continues. So if we were going to use toothpicks to model the fourth figure, you can either do that actually with toothpicks or you can just do it in a drawing. So figure 1 had 4, 6, 7, 8, 9, 10. Here we go. So now I can draw figure 4 would have 1, 2, 3 more. So if each time we are adding 3 to get to the next term in our sequence, that means that our next one is going to have 13 toothpicks. And what about in the fifth figure? Well, if figure 4 has 13, then figure 5 must have 13 plus 3, which is 16. Okay. Pretty easy cheesy. Meet me on the next page. All right, so we're going to keep this toothpick pattern continuing. So we have an in and out table here. It's called an in and out table because we have an input and an output. So the input in this case is the figure number. So figure 1, the output has 4 toothpicks. Figure 2 has 7, 3 has 10, and so on and so forth. It's also called an X and Y table because this the first part is usually called X, the second part usually called Y. So you'll hear this called an in and out table. You'll hear it called an X and Y table, pattern table, lots of different things. So if we continue this on, right, we said figure 4 had 13, figure 5 had 16. If it keeps going, then we would have 19 and 22, okay? So what do you notice about the number of toothpicks needed for each new figure? Well, we kind of talked about that in the previous page, that we are adding, each is 3 more than toothpicks, I should say. This is hard to write on here with a stylus. Than the last. So each figure has 3 more toothpicks than the last one. So using that rule of add 3, if figure 7 has 22 toothpicks, figure 8 would have 25, and figure 9 would have, 28. Okay, so let's look at this new pattern. We're still going to come back to this particular in and out table because we're going to be comparing our next pattern with this one. So looking at example 2 says, start with figure 1 again, add 6 toothpicks for each new figure as shown. So we can already tell our rule is going to be add 6 each time, right? So 4 plus 6 equals 10. 10 plus 6 equals 16. 16 plus 6 equals what? Go ahead and finish this table out for me and then come back. All right, so 16 plus 6, we get 22. 22 plus 6, we get 28. 28 plus 6, we get 34. And 34 plus 6, we get 40. Okay, so continuing on, now let's compare this pattern we just did with the pattern before. Okay, So the number of toothpicks in figure 2 for the pattern on the previous page, let's figure out how many that is. Figure 2 had 7 toothpicks. Is how many less than the number of toothpicks for figure 2 in this pattern? Well, this pattern's 10. The previous pattern is 7. Therefore, it would be 3 less or 3 fewer toothpicks. Okay. Then the next one, we're looking at figure 3. So in our first one, figure 3 had 10 toothpicks. This one, figure 3, had 16. Therefore, I'm getting all mixed up. So, okay, 10 and 16, that means that it is 6 less than the number of toothpicks for your figure 3 in exercise 2. Okay. All right, so we're going to go ahead into the next lesson, but really quick, let me erase. All right, so for this practice page, you can either go ahead and work on this now, or you can watch the next video and then do all your practice pages together, or I should say the next part of this video. Either way, whatever works for you, but essentially what you're doing on this page is you are going to identify how many are needed for the next figure, and then you are going to either compare how it's different from the pattern in the activity on the first page, so the one with the toothpicks and the squares that they added onto, or how does this pattern compare to the pattern for exercise 5? Exercise 5 is this one right here, because it's exercise 5, problem 5, number 5, whatever the case may be. Okay. All right. If you are working on this page first before you continue the video, go ahead and pause. If not, then go ahead and flip to page 513 for me, please. All right. So now we're getting into, instead of looking at figures or drawings, we're going to be looking at just the numbers and figuring out what's going on. Okay. So a pattern, the vocabulary words that we'll be using are a sequence and a term. So a sequence is a list of numbers that follow a certain rule, and each number within that sequence is considered a term. Okay. So you can see that 4 is a term, but 4, 8, 12, 16 is the sequence. And we use the ... to show that that pattern is going to continue on. Okay. So in example 1, it says Mary and her friends find a 4-leaf clover during lunch. A 4-leaf clover has 4 leaves, hence 4-leaf clover, right? The table shows the number of leaves for several 4-leaf clovers. Extend means continue the pattern to find the next 3 terms. Okay, so when we're finding the next 3 terms, we're going to find the next 3 numbers. Okay, so we're going to be looking at this, and there's different ways that you can examine an in and out table or an XY table to figure out the pattern. So as each X gets bigger, as each 4-leaf clover amount increases, the number of leaves increases by 8. Okay. We could also just focus on how does it change in the Y section to determine what our rule is. Okay. So in this case, 4 to 8 to 12 to 16, at first, here's what I have a lot of kids that do. They go, oh, well, 4 times 2 equals 8, therefore my rule is times 2. Well, sure, that works for the first one, but we have to try that and make sure it works for every term in the sequence before we can set that as our rule. Because what you're going to find is patterns often in that first transition, or that first from one term to the next, it might look like you have a rule. You could actually think you have 2 or 3 rules depending on what operation you're using, but you have to try each one to make sure that it works completely. Okay. What I mean by that is if I decided, oh, well, 4 times 2 is 8, but 8 times 2 is not 12. Therefore, times 2 or multiply by 2 is not the rule. So then we would try addition. 4 plus 4 is 8, 8 plus 4 is 12, 12 plus 4 is 16. So we can add 4 to the previous term. So that means 16 plus 4 is 20. 20 plus 4 equals 24. And 24 plus 4 equals 28. So therefore, the next 3 terms are 20, 24, and 28. Okay, patterns are not hard. However, If you don't take the time to really make sure you're figuring out what that rule is, then you're going to be making careless mistakes left and right. Okay, go ahead and meet me on the next page. All right, friends. So in example 2 says Maria and Jong are training to run a half marathon. A half marathon is about 13 miles. Their weekly training plans are shown in the table. Use the information to write a sequence to represent each person's weekly training plan, then compare the plans. So Maria starts at 2 miles, and then she adds 2 miles each week for the next 4 weeks. So we're going to write a sequence with 5 terms for Maria's training plan. Well, it starts at 2. You can't just start at 0. It tells us it starts at 2. So 2, then we have to add 2 for the next 4 weeks. So go 2, 4, 6, 8, 10. Okay, there should be a comma right here. Sorry. Then Jong, he starts with 4, and we add 4 miles each week after. So we're skip counting by 4s. 8, 12, 16. Well, it's not. There we go. 20. So compare the training plans each week. Jong plans to run how many blah, 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 as many miles as Maria. Well, each week, so we're comparing 2 to 4. We'll added 2 miles there. So does +2 work for all of them? 4 plus 2. Oh, no, that's not 8. So we need to try something else other than addition. So we're going to try multiplication. 2 times 2 is 4. 4 times 2 is 8. 6 times 2 is 12. 8 times 2 is 16. 10 times 2 is 20. Okay, so twice as many miles. Okay, notice how I checked each term in the sequence before I decided that that was in fact the pattern. Because like I said, sometimes there's going to be patterns that try to trick you that work for the first 3 and then stop working after that or something like that. Okay. All right. Meet me on the, hang on one second. All right, let's scroll down and do the guided practice together. So go ahead and do this one, then pause the video and check back in with me. All right, so write the next 3 terms in the sequence, 1, 4, 7, 10. So we need to think, how do I get from 1 to 4? I add 3. How do I get from 4 to 7? I add 3. 7 to 10, add 3. Okay, so that rule seems to work for all of them. So if we add 3 each time, 10 plus 3 equals 13. 13 plus 3 equals 16. 16 plus 3 equals 19. Therefore, the next 3 terms are 13, 16, 19. Right? So meet me on the next page so I can make sure you understand the directions really quick.